All right, let's talk about what's going to be on this test. I'm not necessarily going to, because we still have to go over that homework, but I'll just give you a rundown what's going to be on it, what numbers what. I probably won't do any actual examples, but if you see something that we talk about here, most likely you'll see it on that review that I gave you to do. So you could ask questions, like specific questions then. I'm just going to give you a general rundown of what's going to be on the test. Number 1, area of a triangle. Area of a triangle. All right, it's just straightforward, I think. Pen's been writing weird today. Area of a triangle. So, yeah, I give you the base and the height. Couldn't be any easier, right? So how do you find the area of a triangle? That's it. It's just base times height. Am I just writing too fast? Is that why this pen is acting weird? Yeah, area is base times height divided by 2. So I give you a base, I give you a height. Make sure you do what? Write the correct units. If I could get this thing to write correctly. All right. Make sure you include the units. If you don't, hate to do this, I really do, but I'm telling you, all right, and this is part of the instructions, all right, if you do not put the units or the correct units, okay, guess what I'm going to do? I'm going to mark it wrong. Everybody hear me on that? Okay, so make sure that you use the right units, okay, and you do it correctly. So area, if it was in centimeters, what would the area be? It would be what? Centimeters squared. So make sure that you do that. Write that down somewhere, all right, so you don't forget. And if you get all mad at me, Mr. Hamrick, I got the problem right. I just forgot the units. Why'd you mark it wrong? Well, I'm going to refer you to this video, and I'm going to say, I told you to put the units in there correctly. Everybody hear me? All right. I don't know if I need to say that anymore, do I? So, area of a triangle, and then we do area of a parallelogram. That's number 2. What's the area of a parallelogram? It's just the base times the height. Remember, the height and the base have to be what to each other, though? Parallel? That's what I'm asking. Perpendicular, thank you. The base and the height have got to be perpendicular. All right. Perpendicular is a word that my geometry students don't seem to remember, because my 2 CP classes earlier today, I talked about something being perpendicular, and they just had no idea what perpendicular was. Now I reminded them, like, oh yeah, that's perpendicular. All right, area of a square. Again, a square is a parallelogram, so you could go base times height. Or what do they do on a square? Since all the sides are equal, they call it side squared. All right, so if you want to do it that way, but you could just go base times height. Doesn't matter. All right, and then 4 is the area of a circle. Area of a circle. Oh, that brings us to this special day today, I guess. I don't know. People get all excited about Pi Day, and people think I should. In fact, I was looking at my Facebook, and it shows you, stuff that happened years ago or whatever. And I had all these people, happy Pi Day, Mr. Hamrick. You must be so excited. It's Pi Day. And really, I don't care. It doesn't. The fact that it's March 14th means nothing to me as far as being pi 3.14. I get it. I understand I don't know, it's not really a joke, but, I get the relationship between the two things. But like I said, I'm a grumpy old man, and it doesn't really thrill me as much as what it does for other teachers. And that's fine. They can have fun with it. That's good. I'm just not that fun. So how do you find the area of a circle? What is it? Area of a circle. Pi what? R squared, okay? Now, I'll give you a little hint. I shouldn't do this. I should make you think about this on your own. But they're not going to give you the radius. They're going to give you what the circumference is. Okay? So they put a number here, all right? So they give you the circumference. How is that going to help you find the area? To find the what? Okay, you could find the diameter. Or you could just go c equals 2 pi r, right? So you could just solve for r with circumference and then take that radius and then do what to it? Plug it in for that to get the area, okay? Everybody with me? All right, so I gave you a big old hint right there on number 4. So I'll give you the circumference, okay? It'll be a number, okay? It won't be 2 pi r. It'll be a number. And then you find the r, you find the radius, then you take that radius, you put it into here, then you can find the area, okay? Let me see my answer key. Yeah, let's, all of them come out. Yeah. You could keep it in terms of pi. You could keep the answer in terms of pi, or you could put it into a calculator, give me a decimal answer. It doesn't matter. I don't care one way or the other. Does that make sense, what I just said? All right, so if you have a pi in there, if you want to keep it in terms of pi, right? Like, so if your answer came out to like 10 pi, you don't have to go 10 times 3.14. If you want to just keep it 10 pi, perfectly fine. Everybody got that? All right. All right, then, so these are all just sentences, okay? They tell you, like on the square one, they'll tell you what the side is, all right? It's not a picture, right? So 1 through 4, there's no pictures involved. They just say, find the area if the base was this, if the height was this, or find the area if the side was this, all right? And then you just find it. 5, 6, and 7, they give you pictures, and you got to find the areas, okay? So 5, well, let's do it like this. So 5, 6, and 7, they do give you pictures, and you just have to find the area of that particular picture. And they'll mark the stuff on the picture and that kind of thing. So 5 is the area of a trapezoid. Let's just review briefly what the area of a trapezoid is. Do you remember that? This one's the one that's a little bit more difficult, not much. Yeah, you could put a half in front, but sometimes people like this a little bit better. And that's the same thing. Oops, why does it keep on doing that? All right, so you could write it like this, or you could put the half in front of it and not have the over 2 in there. Either way, it's the same thing. All right. Oh, of course. It's times the height. So it's this times the height. Sorry about that. That's correct. All right, and that's how you find the area of a trapezoid. Okay? Alrighty. Or how did we write it? I think 1/2. This pen's driving me nuts today. B1 plus B2 times H. Same thing, right? Yes. All right, number 6 is a kite. Area of a kite. Do you remember that? They'll give you diagonals on this one, because remember we did a problem when it didn't give you the diagonals? You had to do a little extra. But they will give you the diagonals on this. So what's the area of a kite in terms of the diagonals? Diagonal 1 times diagonal 2? Was that it? Wasn't there a half in front of it? Yeah. It's 1/2 D1 times D2. Okay? So that's the area of a kite. And the area of a rhombus is next. And again, they're going to give you diagonals on this one. Okay, so what is that? Same thing, isn't it? Yep, kite and rhombus, same thing. Yep, so 1/2 D1 D2. We good? All right. So that's all the area stuff. Well, let's see. Yeah, there's a little bit more area. Yeah, there's some more area, but then you got that middle section. Remember that little middle section we did with Pythagorean theorem and 30, 60, 90 and all that stuff, 45, 45, 90. So that's what we're into right now. And then it jumps back into area again later on in the chapter. Yep, so that was the first part. That was the first area stuff. That was really straightforward. That shouldn't be all that hard. Everybody should get every one of those problems right. And then You have number 8, where you have a Pythagorean triple. Do you remember your Pythagorean triples? Let's list a few of them. What are they? What's the smallest? 3, 4, 5, okay? And then what was the next one? 5, 12, 13. And then what was the next one after that? Look in your notes. Wasn't it section, I don't know, what, 7, 4, 7, 5 maybe? I don't know. I can't remember. 8, 15, 17. What was the last one? Yeah, 7, 24, 25. Sometimes I forget those. All right, but I could have any of these on there for Pythagorean triples. So I give you a picture. It's a right triangle. Remember, these only work with right triangles. So I'll give you a picture. You'll see a couple sides, and you find the third side. And really, there's really no math involved. You just look to see which Pythagorean triple it is, find which one we're missing, and that's going to be the side that they ask for, okay? So 8 should be easy. You should be able to do that in a matter of just seconds, literally, all right? You shouldn't even have to do any math at all. You just look at it. It's going to be one of these. I'll tell you right now. It's going to be one of these, and you just tell what the third side is, okay? They give you 2 sides. You just ask for the third, or they ask for the third. All right. So number 9 is, it's going to be Pythagorean theorem. So I'll give you a triangle. I'll give you 2 sides, and you're going to have to find the third side, and you're going to do it by Pythagorean theorem. Do you remember what the Pythagorean theorem is? A squared. Been complaining about this pen all day. I think every time it acts weird, I'm going to say something, so sorry about that. But anyway, there you go. So that's Pythagorean theorem. Number 9, you're going to just put it in, solve for a missing side, and you should be good to go. And same with number 10. So number 10 is the same. All right? I would review the quizzes. All right? The quizzes are probably the best thing to review for this test. I didn't put the quizzes up on here. Sometimes I do when we review for a test. But you got the quizzes. I've given them all back to you. All right? We've talked about them. So just make sure you review the quizzes. But I'm showing you number by number what's on here. Then this one is tell whether it's right, acute, or obtuse. So I give you 3 sides. I give you 3 sides of a triangle, and you have to tell me, is it a right triangle, is it an acute triangle, is it an obtuse triangle? Okay? How do you do that? Now watch very carefully. A couple of you messed it up on the quiz because you didn't do what I told you to do. You guys are still, when you do this comparison thing, you guys are still going a squared plus b squared equals c squared. I would not do that, all right? I would do this. I would take the c squared first. Everybody watching? All right, because some of you guys did this. I would take the c squared and then compare that, there we go again, to the a squared plus b squared. So if it's equal, what kind of a triangle is it? It's a right triangle. If c squared is less than, then it's an acute triangle. And then if c squared is greater than, then it's a what? It's an obtuse triangle, all right? Some of you guys are getting it mixed up. You're doing the a squared plus b squared, putting on the left, and then you're saying, oh, a squared plus b squared is less than c squared. Oh, that must mean it's acute. That's not true. It would be the other way around. It's a lot easier doing it this way. Put the c squared first. Now somebody, I think one person, they took the a squared plus b squared, and it was like, I don't know, less than c squared, and they said this was obtuse. That would be true, wouldn't it? But less than and obtuse, in my mind, don't really go together, do they? Less than and acute would go together. So if it was c squared is less than, then it would be acute. But this is c squared is greater than. Anyway, if you understood that, great. If you didn't, that's fine. Do it like this, all right? Set it up like that. I think that will save you some problems than doing it like this, all right? If it was an equals, it wouldn't make any difference. But if it's an inequality, it absolutely, I think, makes a difference. So that would be obtuse. If it was less than, it'd be acute. If it was equal, it'd be right. So I give you 3 numbers, all right? And you just got to put them in and then compare them and see what they are. Everybody with me? Oh, I got a random text. Would you like to come over to my place tomorrow? Oh, sure. I would love to. Where's your place? No, I delete. I don't just delete them. I block them, but they still send them to me. You ever get that stuff? Yep. Hey, how you doing today? All that kind of stuff. It's like, but I block them every time. All right. 12 and 13. Well, 12 is a 45, 45, 90 triangle. Remember that? So, what do we know? We know one thing about the 45, 45, 90 triangle, don't we? The hypotenuse is what? Do you remember? Something you got to know. Square root of 2 times one of the legs. Okay? That's what you need to remember about a 45, 45, 90 triangle. Say that again. Both the legs are the same. Yeah, 45, 45, it's an isosceles triangle, right? Because if the two angles are the same, the sides opposite are going to be equal to each other. So yeah, it's going to be an isosceles triangle. So both of the legs are the same, but the hypotenuse is square root of 2 times one of the legs. What does that mean? It means the hypotenuse is about 1.4 times as big as the leg every time. Doesn't matter how big your right triangle is, doesn't matter how small your right triangle is. If it's 45, 45, 90, the hypotenuse is always the square root of 2 times one of the legs. All right, 13 is a 30, 60, 90 triangle. Now there's two things to know about a 30, 60, 90. And they both relate to the what? The short side. Okay, so let's do the hypotenuse first. That's the easiest one, I think. So the hypotenuse, I don't know what I'm doing. Am I writing on it wrong? Maybe this tip needs to be changed or something. I don't know. The hypotenuse is equal to what? 2 times the short side. So it's double. Okay, so whatever the short side is, you double it, that's the hypotenuse. Pretty easy, isn't it? If you know the short side. Sometimes you don't know the short side, all right? And that takes a little bit of extra work. But if you know the short side, if you just double it, that's the hypotenuse. What if you know the hypotenuse and you're trying to find the short side? What would you do with the hypotenuse? No. You just divide it by 2. That's right. If you know the hypotenuse, okay, you would divide by 2 to get the short side. Make sense? All right. What was the other one? The long side, right? That also relates to the short side. It's something times the short side. It's the square root of 3 times the short side. Everybody see that? They both relate to the short side. That's important to understand. It makes it a little bit easier to remember which one's which. So I'll give you a picture. I'll give you the angles, and then I'll give you one of the sides, and you got to find the other 2 sides. You got it? So I'll give you a 45-45, which would kind of look like this. All right? This and this are equal. I'll give you one of the sides. I'll give you either one of the legs, or I'll give you the hypotenuse, and you got to find the other 2 things right here. I'll give you one. This is 30, 60, 90. So that's 30 degrees, that's 60 degrees. I'll give you one of them. I'll either give you the short one. This would be the short one. How do you know this is the short one? Just because it looks like it's short? Because it's across from the 30. Very good, because that's the smallest angle, so that's the shortest side. So this is the hypotenuse because it's opposite the right angle. This is the longer leg because it's opposite the 60. So I'll give you one of them, and you got to find the other 2. So that's for 12 and 13. There's 2 answers. You got to get them both right to get that problem right. Everybody hear me on that? So 12 and 13, there's 2 answers for that. You got to get them both in order to get the problem right. Okay, moving right along. 14. Now we're kind of getting to that, well, no, I was going to say something else, but. Remember you had like a regular, I'll do a little picture here. Remember you had a regular polygon? It's going to ask you some stuff. First thing it's going to ask you about is the central angle. Do you remember what that means? So that means if I drew from the center to that vertex and I drew from the center to really any vertex, I'm asking for the central angle. That would be this angle right there. We'll call it theta. How do you find that angle? If this is a regular polygon, how many sides does this one have? 1, 2, 3, 4, 5, 6. 6 sides. So how do I find that angle if that's a regular hexagon? You got it. 360 divided by 6. It's that easy. All right? And that would be what? 60 degrees. So that central angle would be 60 degrees. So that's the kind of thing I'm going to give you. They don't give you a picture. They just say, what is the central angle of a regular whatever? In this case, it's a hexagon, okay? So the question would be, what is the central angle of a regular hexagon? I'll tell you right now, it's not a hexagon on the test, okay? Everybody hear me? But that's what you would do. You just count how many sides or how many angles, 360 divided by how many angles you have, and then that's your central angle. It's that easy. And then it's going to ask you to find the area. Okay, it's going to ask you to find the area of a regular polygon. Do you remember how do you do that? There's a little formula. Anybody remember? Look it up in your notes. I want you to look it up yourself so I don't have to just tell you everything. The area of a regular polygon. It was just recent, right? It was just like a lesson ago, 2 lessons ago, maybe something like that. Was it the last lesson we did? I don't know. I can't remember. It was pretty recent. Area of a regular polygon. You got it. Okay, and that's why I want you to look it up, because you need to be doing that kind of stuff on your own, all right? If you see something, and you're like, oh, I got to find the area of a regular whatever, hexagon, octagon, decagon, whatever. Like, how do I do that? Well, look in my notes. Okay, there's got to be a formula somewhere. And sure enough, there it is. What in the world is the apothem? Like in this one right here, if I asked you to find the apothem, what would the apothem be? It's from the center, perpendicular to one of those sides. I would rewatch this lesson. It sounds like you're a little lost on this. All right, so I would rewatch the lesson if I were you. You don't have to watch the whole entire thing. Just, fast forward till you get to this part right here. All right, just watch that little section of it. All right, so that's the apothem. What's the perimeter? The perimeter is the distance around the whole thing, right? So, I don't know, I'm making a number up here. What if it was 5? How would you find the area of that? 5 times 6, so it's 30, right? So the perimeter is 30. Then you find this one right here. Let's do this one right now, okay? I got it up here, might as well use it. So how would I find the area of this if that was 5? Well, you got to find the apothem, right? So how do you find the apothem? Well, it's the longer side of this right triangle. What's this angle inside of here? The whole thing is 60, correct? What's this little one right here? That'd be 30. So if that's 90 and that's 30, what's this one down here? It's 60, okay? So you got a 30, 60, 90 triangle, don't you? All right. And so what would it be from here to here? What would that short side be? Would it be 5? 2.5, right. So this would be 2.5. Remember, because each side is 5, right? So that whole side is 5. This would split it in half. That would be 2.5. This is the short side, isn't it? So how do I find the long side, which is the apothem? Times the square root of 3. Very good. So this would be 2.5 times the square root of 3. And then what do you do to find the area? You just go 1/2 times the apothem. What did we say it was? 2.5 times the square root of 3 times the perimeter. What's the perimeter of this thing? It's 30. And then you put that in your calculator and get a number. Okay? So right now, finding the apothem, the only ones they're going to give you is when you can figure out what that apothem is with either a 30, 60, 90 or a 45, 45, 90. Later on, when we do trigonometry, all right, trig, as we shorten it to be, this could be any angle. This could be like 37 degrees, and you're going to be able to find what that length is, even though that's a weird angle right there. But you can't do that right now, okay? You haven't been taught that stuff, but you will, okay? The very last chapter that we do in this class is going to be trig, right? And so you will be able to find that side if that was like 37 degrees, something weird like that, all right? But right now, you don't know that stuff, so they're only going to give you stuff that you can do. So they'll just give you a 30, 60, 90, or they'll give you a 45, 45, 90, all right? Those are really your only choices at the point that you're at right now. Make sense? All right. What are we on? That was 14. That's 14 and 15, basically. I did two of them. The central angle one was 14. 15 was the area. All right, so this would have been 15. We good? All right. All right, then we did the thing with the circle. Remember that? Yeah, we just finished doing that. That was the last lesson we just did, isn't it? So let me put the center right here. And I think we just answered a question yesterday that was like this, didn't we? Yeah. Wasn't it like the first one or something? Somebody asked it, so we went over it. So that should be fresh in your mind. All right, there you go. And so it says find the area, the sector, and the segment. We already did it yesterday. I'm not really going to go through it again today. So what is the sector? The sector is that whole thing right there. Agreed? What is the segment? The segment is just this stuff right in there. Okay? You should be able to find the area of the sector, fairly straightforward. And then the segment, how do you find the segment? You take the whole, you take the whole sector, then you find the area of the triangle, take the triangle away from the sector, and you got what's left over. Right? We did that yesterday. I'm not going to do it again. 18, 19, and 20 are those where they have the shaded region. Okay? So 18, 19, and 20, you're finding the area of the shaded region. Again, we did that yesterday. So I'm not really going to do any specifics today, but we spent quite a bit of time on it yesterday. All right? So 18, 19, and 20 is going to be the area of a shaded region. And there you go. That's the test. How do you feel about it? Yeah? Well, 14 and 15 were these, okay? And then 16 and 17, I didn't write it down. 16 and 17 was this thing right here. Area of the sector, area of the segment, okay? And then 18 to 20 is the area of the shaded region stuff. I mean, this technically is area of a shaded region, isn't it? All right, but the other ones, it's not using sector and segment. It's just, part of a circle or a part of, when you have like a circle inside a triangle, you take the circle away from the triangle. Remember those kind of things? Yeah, it was like the last thing we did, I think, on the homework. That's 18, 19, and 20. Alrighty, that's it. Ready to go over the homework, that chapter review? All right. Do you want me to record that or just, I guess it wouldn't hurt, would it? Might as well. All right, so now what are we doing? Going over some homework. Do you need me to read some answers off? Probably. What'd you have? 3 to something, right? And every third? Where'd you go? 45? All right. So let's just take the even ones. Did you check the odd ones yourself when you worked on them? All right, so let's just read the even ones off. So that would be what? 6 was the first even one? That would be 72, and that's miles squared. Did we do that together in class yesterday? At least I got you started on it, I think. I don't know if we did the whole thing. 72 miles squared. And then, let's see, 6, 9, 12. 12, right? 40.6, all right? 40.6. And that's, they don't give you any units. So if they don't give you units, how would you write it, the area? Just units squared, right? Units squared. What's that? It could be. I mean, it's not ridiculous to ask something like that. There's not going to be one that looks exactly like that. Okay, but it's legitimate that it could be on there if I wanted it to be. What's that? 15, 18. 18. So 18 is 8 millimeters. 8 millimeters. And then, what's the next one? 24. That's, they say find the exact area. Now, I don't do that on the test, okay? I don't say find the exact or find the decimal. It's up to you. But in this problem, it's 108 times the square root of 5. 108 times the square root of 5. And then let's see, 27, then 30. 30 would be, again, exact values. They ask for A, B, and C. So number 30 is 15 times the square root of 3. That's part A, sorry. So not part A, but line segment A is 15 square root of 3. This is all in meters, by the way. Part B, or side B, is 30 meters, 30. And then C is 15 square root of 2 meters, 15 square root of 2. All right. And then, let's say 33, 36. Says, what's the degree measure of the central angle? That would be 30 degrees, 30 degrees of a dodecagon. What's a dodecagon, by the way? 12 sides. Very good. All right. Then what do we got? 39, 42. 42 would be 12.7, and that's inches squared. Excuse me. 12.7 inches squared. And that's all the evens, right? All right. Any of those you want to do? Go over? What is it? 30? Okay. Let me see where number 30 is. Oh my, okay. All right, let me draw this thing. Looks like that does that. That does that. Then this is a right angle, so. And then this is a right angle. Yeah, it's not too bad. Let's make this go to there. Okay, so that's what that looks like. And then they put a dotted line. Still don't know how to do dotted lines on this. I know there's a way. It's got to be easy. One day I'll figure out how to do dotted lines with this thing. And let's put some other things in here. They get that as a right angle. That's a right angle. This is A. This is B. Oops. B. C is down here. And they tell you that this is 45 degrees. That angle right there. They tell you this is 60 degrees. So we got a 45, 45, 90 and a 30, 60, 90, right? It's like a combo thing. And you got to find A, B, and C. All right. I'll tell you what. Do they tell you sides? Oh, yeah. I knew they had to tell you a side somewhere. So that's 15, and it's in meters. And that's all they tell you. Yes, I got it all now. All right. Wow. What's that 15? It's part of this 30, 60, 90. Do you understand why this is 30, 60, 90? Because you got a 60, you got a 90. This has to be what? 30. If this is 45 and that's 90, what's this have to be right here? That has to be 45. Okay. So let's just concentrate on this triangle right here, that 30, 60, 90. Which one do they tell you? Do they tell you the long side, short side, or hypotenuse? The short side, okay? So that's when it's the easiest, right? When they tell you the short side. So what would you find first? I mean, A comes first, but what's the easiest thing? Yeah, you could do the long side, but to me, I just like to do the hypotenuse, right? So just double it. So what is B? It's just 30. Get this thing right. That's 30, okay? And then A, I don't know, some people might argue that A is even easier because right here I had to know what 15 times 2 was, all right? Wasn't that hard, but I still had to do some math. Right here, I really don't have to do any math. What do? Take the short side and do what to it? Multiply it by square root of 3. That's right. That's all I got to do there. Make sense? C is probably the hardest one to do. But look, C is one of the legs of this 45, 45, 90 triangle. What do I know? What do I already know about the 45, 45, 90? I know the what? The hypotenuse, okay? Because it's the hypotenuse to this one, and it's also the hypotenuse to this one. So let's write that down. Let's write hypotenuse. On a 45, 45, what is it? Hypotenuse is the square root of 2 times one of the legs. Well, what is one of the legs? Let's use the letter C, okay? And then let's replace hypotenuse. What is the hypotenuse? I know the hypotenuse to this. What is it? You just told me a second ago. What is the hypotenuse to this triangle? It's 30. So how do I solve for C? Divide by what? Square root of 2. Now, watch very carefully, though. Do we want to leave it like this? No. Why not? Why is that not simplified? Square root on the bottom. Okay? Square root's on the bottom. They don't want you to leave it like that. So what are we going to do? I'm going to rewrite it. 30 over the square root of 2. What do we do to it to get rid of that square root? By 1. Well, yeah, it is by 1, which would be square root of 2 over 2. Good. Which is multiplying by 1. Exactly right. Why do we do that? Because that gets rid of our square root on the bottom. Because what is the square root of 2 times the square root of 2? Just plain old 2, right? And now what do you have? 30 square root of 2. So most of the work was not the geometry. Would you agree? Okay, it's just simplifying this thing. What do we do now? 2 goes into what? 30 15 times. Does the 2 go into the square root of 2? Can I cancel those out? No, because that's a square root of 2. That's not a 2. All right, it's like 1.414. All right, it's not a 2. So now what do I have? I can't do anything else. So what's my answer? 15 square root of 2. Tell you what, you get used to doing this square root stuff now. When you get to Algebra 2, you're going to have a good head start, okay? Because we will do a lot of the square root stuff eventually. We haven't yet in the Algebra 2 class where we are right now, but eventually we're going to get into it pretty soon. So that's definitely a good skill to have to be able to simplify with square roots. So that's how you do that one. That was number what, 30 on the chapter review? Are they the answers I read off to you? I think so. Anybody else? Got a few minutes. We can do one more. It's up to you. Which none? 12? Okay. All right, let me find number 12. It's the one you guys have been talking about. All right, if I can draw this thing, let's give it a shot. So I got this, and then got this way out here. Then I got this one, and this one. Where does it go to? About right there. And then, yeah, I'm not going to try to make the circle perfect like I did yesterday. I'm just going to try to draw it. It's going to be ugly, but beware. Oh, I know. That's not too bad. Okay. So what do we know about this? This is 12. From here to here is 12. Everybody see that? And then this is 5, and this is 5. This is what, 3? Yeah. And you got to find the area of that whole thing. All right, well, yeah, let's do it like this. I'd put a little dotted line there. Just find the area of this thing. What is this? It's square, isn't it? 5 times 5, so what's that? 25. And it's in what? What's it in? Doesn't say. So we'll just put it 25. So now, watch this. Let's put a little dotted line right here. Let's just find this. So how do I find that? Yeah, 7. Where'd you get the 7 from? Very good, because from here to here is 5, isn't it? That whole thing is 12, so what's it from there to there? That's 7. What about this right there? It's 2, isn't it? Because the whole thing from top to bottom is 5. That's 3, so what's that? That's 2. So let's just find this rectangle. 2 times 7 is 14. So inside of here is 14. Inside of that is 25. So now all we got to do is find this semicircle. All right? So how do we find the area of a circle? Pi r squared. But if it's a semicircle, it's how much? It's half of a circle. So what's the radius of this circle? Is it 2? It's 1. That's right, because from here to here, that would be the diameter of the circle, correct? So we want to find the radius. The radius would just be 1. All right, so how do we do that? It's just pi times 1 squared is 1, so it's pi over 2. That's the area of that semicircle. And you just add them up, all right? 25 pi plus 14 plus pi over 2. Do that in your calculator, all right? Put that in your calculator, add the 14, add the 25, and hopefully you'll come up with 40.6. All right? It doesn't give you any units, so you should always write what? You could just put u squared, that's what the book does, or you could put units squared. And there you go. There won't be anything this complicated on the quiz. But that really, I mean, that's legit, or the test. Right, it wouldn't be terrible if I did put it on there, would it? No. Yeah, it was kind of easy, wasn't it? What was the part that tricked you? Finding that 7 and 2? Yeah, if you don't split it right. Yeah, because if you went this way, I don't know, you might still be able to do it. Yeah, because you could go 5 times 3 is 15, right? If you split it like this, then this right there would be 15. This would be what? It would be 12 times 2, right? Which is 20, what, 4. So you could split it that way and still get it. Right, so you don't have to do it the way but that's the way I saw it, and that's the way I split it. And you can still do it that way. All right, we good? All right. All right, we're closing it down. And test is what, Monday? All right. Don't forget about it. Set an alarm or something on your phone, maybe Sunday night, right? To do some studying on Sunday night before you come to school on Monday, so it's fresh in your brain, and then you're ready to take it on Monday. I don't usually like giving them on Monday, but that's the way it is, and that's what we're going to do. Nah, let's take it on Monday. Let's get it over with. All right, we'll be good to go. All right.